Welcome back to another session of Understanding Human Anatomy. In this lesson, we're going to talk about the mechanism of respiration. And one thing you have to understand is that the lungs are not capable of moving on their own. They are literally huge sponges with air sacs in them. But they have no muscle, nothing that will cause them to move. The movements of the lungs are entirely passive and dependent on our skeletal musculature. Now, to understand what's going on, we have to look at various pressures. There is a pressure within the lung, and that pressure is the intrapulmonary pressure. So the pressure here inside the lung is termed intrapulmonary pressure. Intrapulmonary pressure, at least at the beginning of inspiration and at the beginning of expiration, intrapulmonary pressure is equal to atmospheric pressure. It's equal to the ambient pressure surrounding the body. Now, if we measure the pressure within the pleural cavity, that pressure is known as the intrapleural pressure. So the pressure here, and remember I've exaggerated the size of the space, but if you measure the pressure in here, it is the intrapleural pressure, and the intrapleural pressure is slightly less than atmospheric pressure. So we can say that intrapulmonary pressure is greater than intrapleural pressure. Intrapleural pressure is less than intrapulmonary pressure. Finally, we can measure the pressure within the thorax, between the pleura and the body wall. This is the intrathoracic pressure. And I'm going to draw the arrow into the mediastinum because I have no room to put it between the pleura and the body wall, but the same pressure should be here in the mediastinum. It's the pressure outside of the pleura. And the intrathoracic pressure is less than intrapleural pressure. So, let's look at this on a clean slate and restate what I've just said. Atmospheric is equal to intrapulmonary pressure. Intrapulmonary pressure is greater than intrapleural pressure. And intrapleural pressure is greater than intrathoracic pressure. Now, what that means is that we have a bit of suction that holds these structures together. Let's go back to the last slide. If intrapulmonary pressure is greater than intrapleural pressure, then the greater pressure in the lungs will force the lung to move up against the parietal pleura. So the surface of the lung, specifically the visceral pleura, will get pulled up against the parietal pleura such that any change in the parietal pleura will induce a change in the size of the lung, the volume of the lung. With the intrapleural pressure being greater than the intrathoracic pressure, that means that the parietal pleura is also pulled up tight against the body wall. The parietal pleura gets pulled up against the body wall. so that any change in the body wall will result in a change in the pleura. So if we expand the body wall, make the thoracic cavity larger, the pleural cavities will enlarge. And as the pleural cavities enlarge, the lungs will enlarge. Conversely, if we make the body wall smaller, we reduce the volume of the thoracic cavity, then we'll also reduce the volume of the pleural cavity and will reduce the volume of the lungs. So we breathe by changing the volume of the thoracic cavity using skeletal muscles. Okay, now we need to again go to a clean slate to talk a second about gas law. Now, I'm not going to go over the whole ideal gas law equation. We're going to look at just a part of the ideal gas law, because when we're talking about movement of air in and out of the lungs, the other components do not change. They're constant. But what does change is volume and pressure. And if you look at the ideal gas law, you'll find that pressure is equal to 1 over volume. Pressure is inversely related to volume. So, if volume increases, then pressure decreases. Conversely, if volume decreases, then pressure increases. So if we change the volume of the thoracic cavity, and by so doing change the volume of the lungs, we'll change the pressure inside the lungs. We will change the intrapulmonary pressure. But since the lung is connected to the outside, if we change the pressure, air will either move in or move out of the lungs to bring the pressure within the lungs, bring the intrapulmonary pressure back to atmospheric. Now, we'll take a break at this point, and in the next video, we'll put all this information together to show you how we move air in and out of the lungs. Thank you for your attention.